So in my previous video, I showed how I made some hardwood flooring for my house. During that process, I was using a shaper with a power feeder on it. Now this is the switch from the power feeder, which broke while I was using it. So it is a stack of individual switches, all put together like Legos, with one shaft which goes down through the middle. So each one these has a shaft and a socket, and they have different set of contacts, and this little thing turns and it'll open and close these contacts. Now the problem is this is a rather large, long stack. It's all plastic, and the cam lobes are very sharp, so trying to turn this is very difficult to do. So it's a stiff switch, and there's lots of layers, and it's all driven by these plastic cams. So I took it apart to see if I could lubricate it, and unfortunately I broke it. Well, I didn't exactly break it, but I was unable to get it back together in the same way it came apart, because this cam piece can go in one of 8 ways with no indication of how it's supposed to go, any one of 8 directions. And when I took it apart, it had turned halfway in between 2 of the other ones, 2 of them, so it wouldn't just fall back into place. It was here, it wouldn't just sink on, it was stuck halfway, so I wasn't sure which side it was supposed to go on. So that was one problem. So I took it apart again, and then the whole cam thing fell out, so I completely lost my location. So I had 8 possibilities, and then in doing that I ended up breaking the rest of the switch. And as far as taking one of these things apart, there's 6 switches, 1, 2, 3, 4, 5, 6 switches, and they can go together 8 different ways, each one of them, and the cams are not the same for each one of these. So if you take one of these apart, there's probably a few million ways it can go back together again. So basically no user serviceable parts inside, but I still needed to use the shaper and the power feeder. So I looked up on eReplacementParts.com for a new switch, which I've gotten stuff from before, and I've had good luck. But the switch was $208, not counting shipping, and it was back ordered for a month. It said 2 weeks to a month it'll ship. So I couldn't wait a month or 2 weeks to get my flooring done, so I decided to try to figure out what this switch did. Even though the top part's taken apart now, I had originally taken just the bottom part off because it seemed like that's where it was sticking. Before I took it apart, I made this diagram with the switch, all the pins, what's jumpered to what, which wire connections go where, and try to document as much as I possibly could. 6 wires coming out of the motor, 6 wires coming out, and 3 were white and 3 were red, and I figured out that W, U, and V, W, U, and V were all on the high speed, and the low speed were X, Y, and Z. Now, I knew that the bottom part of the switch, I was unsure of the switch positions for the bottom section, because when I took it apart, this is where the switch got separated. So the top part I knew, and the bottom part I didn't. So through some trial and error, first of all, the switch has 7 positions: fast reverse, off; slow reverse, off; slow forward, off; and fast forward. So I discovered that on fast speed, it swapped R was connected to W when it was fast forward, and S connected to U when it was fast forward, and when it was connected in fast reverse, it was R and U instead of R and W, and S and W instead of S and U, and then R and Y, S and X for slow speed, and R and Y and S and X for X. So that's taking R and S are the two line inputs, and it's switching which pair of wires is getting connected. The third wire is V and Z, and those are down at this bottom part, which is connected to the capacitor. So I knew one side of the capacitor, and I sort of guessed that that was just switching between those two connections. So I did this fun chart, ended up being completely worthless, trying to map out all the switch positions. It tipped me off that something was broken inside the switch when I got a whole run that never changed, another run that never changed, another run that never changed. It just seemed kind of suspect to me. So after a little bit, I got a message from eReplacement Parts saying that the switch was back ordered even more, and they were unsure of a delivery date. So I decided to try to make a new switching setup using relays, and I mapped out what I need for relays. So this is my basic on-off, switches both hots because it's a 240 volt motor. I figure that's better. Then this circuit, it's hard to read, but it's just basically flopping those two wires for the direction. And then this last part, once again, hard to see, but it's basically a triple pole switch that swaps between these three wires and those three wires for the high speed. So I'll have, so I started wiring up the relays. I have them in here. This is the triple pole relay. These are the two double poles. I have this circuit board, which is going to be a power supply I got from Newark, all pre-built just to make my life easier, because I have power supplies which are 12 volts, but this needs to be 12 volts and taking in 240 volts as the input, which I don't have any power supplies that do that. And then I'm going to use a DigiSpark little Arduino microprocessor to control the relays, because I could just hook up switches to them, and I considered doing that, but there's a possibility I could switch speeds while it was still on. I wouldn't have the intermediary off positions between forward and reverse or high and low, and I want to make sure that everything is stopped before I switch speed or direction. So I can program that into the microprocessor to do that automatically. So that's my current project